हेलो बच्चों, तो आप सबका स्वागत है शौर्य एकेडमी इस यूट्यूब चैनल में। तो आप पढ़ने जा रहे हो फिजिक्स विद वैभव सर। लेट्स गेट स्टार्टेड।
Okay, so hello, we are going to start with the what? The quick formula revision on mechanical properties of fluids. Now see, first formula is what? That is the pressure. So pressure is a what? Pressure is a normal force upon surface area. This normal force is also called thrust. Okay, so symbolically it is what? You can write यहाँ पे that is pressure is equal to force upon area. Now units. First unit is what? Now see, unit is what? Force का unit Newton, area का unit Newton per meter square. It is also called the what? Pascal. Okay. Now atmospheric pressure, different units. What is atmospheric pressure? First, what is the value? 1.0132 into 10 raised to 5 Newton per meter square or Pascal. So this 10 raised to 5 is called the what? Bar. So we can say that is atmospheric pressure is approximately 1 bar. Second, you can say that atmospheric pressure is 760 millimeters of mercury column. You can also say that it is 10.33 meter of water column. Okay, you can also say that this atmospheric pressure is 760 torr. Okay, so these are the different units of atmospheric pressure. Then gauge pressure. Gauge pressure means what? That is the pressure due to a height of liquid column. What is the formula to calculate this? Yes, that is gauge pressure is equal to rho GH. Rho is the what? Density of fluid which is used in the liquid column. It is water, mercury or something. G and H is the height of liquid column. So we are getting the gauge pressure rho GH. Okay. The next, absolute pressure. What is absolute pressure? Yes, absolute pressure is equal to atmospheric pressure plus gauge pressure. Means what? You can find यहाँ से gauge pressure is equal to यहाँ पे absolute P absolute minus PA. Clear? ठीक है. Pascal's law. What is the Pascal law? Yes. Pascal law is what? It says the pressure is constant. Okay, means what? Yeah, from this we have studied the two applications. One is the hydraulic brakes, second one is the what? Hydraulic lift. So hydraulic lift pressure constant means what? Suppose we are considering the two conditions, P1 is equal to P2. So you can write F1 upon A1 is equal to F2 upon A2. Now we have to calculate the what? F2, how much lift you are getting, how much mechanical advantage you are getting. That is F2 is equal to, yes, it is A2 upon A1 into F1. So we know that here we are getting the what? Mechanical advantage, means within less effort you can lift maximum load. Okay, so this is the application of what? Pascal law. Next, surface tension. What is the surface tension? It represented by T. What is the formula? Yes, surface tension T is force per unit length. So from this, what is the unit? Force is Newton, length is measured in meter, that is Newton per meter. Okay, the next, angle of contact. What is the formula? Angle of contact, formula is what? Angle of contact, cos theta is equal to T2 minus T1 upon T3. What is the T2? It is the surface tension due to solid liquid surface in contact. This one is a what? Surface tension due to solid and air in contact. T3 is a what? Surface tension due to liquid air in contact. Okay, so this is a cos theta, where theta is called the angle of contact, and basically you know that whenever we are talking about the ordinary water, for that theta is acute, If you are talking about the mercury, the theta is obtuse, near about 120 degree. Okay, ठीक है. Next is a what? Relation between the surface tension and the surface energy. Yes, that is the surface energy is equal to T into dA. Okay, and from these many more formulas are there. That is when the number of small droplets coalesce to form a bigger drop, or bigger drop splits into number of small droplets. So we already found the radius of bigger drop is cube root of n into small r. So then we observe that is if the soap bubble is there, or so what is the relation? Yes, relation is what? That is E is equal to, yes, below, that is 2, because of soap bubble having the two surfaces, then surface tension, then the 4 pi, okay, in bracket n r square minus r square. If you are talking about the what? Water droplet, okay, then this formula becomes what? E is equal to only one surface, so T into 4 pi nr square minus r square, where n are the what? Number of small droplets or the bubbles. Okay, any doubt? No. Now next. Now यहाँ पे not only soap bubble or the water droplet, there may be a case of surface film also. Okay? Yes. Now excess pressure inside the liquid drop. What is the formula? Pi minus Po is equal to 2 into surface tension upon radius of droplet. Then for soap bubble, it is Pi minus Po is equal to 4T upon R because of two surfaces. And inside air molecules also, it is Pi minus Po. It acts as a condition of droplets 2T by R. T is the surface tension, R is the radius of droplet or the bubble. Okay? Next. The height of liquid column in capillary means what? Rise. Rise of capillary. So what is the relation? That is H is equal to 2T cos theta upon rho Rg. H is the capillary rise, T is the surface tension, theta is the angle of contact, rho is the density of liquid used, R is the radius of capillary, G is the acceleration due to gravity. Okay. The next, radius of curvature of meniscus. What is the formula? Meniscus, that is R is equal to small r upon cos theta, where r is the radius of meniscus, that is whether it is a concave meniscus or convex meniscus. So radius of this one, that is capital R, and small r is the radius of capillary. Clear? The next, net force acting on the liquid column in capillary. What is the formula? Yes, F is equal to T into 2 pi r into cos theta. What is the surface tension? Force per unit length. So force is a what? Surface tension into effective length. So it is 2 pi r into cos theta, which is the what? Net force on the liquid column. Okay. The next, critical velocity. So you know the basic formula of what? Reynolds number. What is the Reynolds number? Yes, Reynolds number is equal to rho V, yes, D upon eta. Okay, so from this we know that the V is the what? Critical velocity. Rho is the density, Vc is the critical velocity, D is the diameter. D is the what? Diameter, and eta is the coefficient of viscosity. Clear? And what is the significance of Reynolds number? It used to determine the type of flow. So what is the range? Yes, when the Reynolds number is what? Less than 2000, then Reynolds number is lies between 2000 and 4000, and when the Reynolds number is greater than 4000. So yes. So what is the type of flow? In the first case, the flow is what? Laminar. In third case, the flow is turbulent. and in between that flow is called transient flow. Okay, so Reynolds number is a unitless, dimensionless. Okay, the next velocity gradient. So first हम देखते हैं Newton's law of viscosity. What is the equation? Force is equal to eta A into dV by dy. Yes, what is the viscosity? It is the resistance between the layers of the fluids. Correct? That is the viscosity. It offers the resistance to flow. Okay, यहाँ से this term is called the velocity gradient. So what is the velocity gradient? It is dV by dy. Is it clear? And important, what is the unit of coefficient of viscosity? Yes, unit. What is the unit of coefficient of viscosity? Force into dy upon A into dV. So just tell me, force in Newton, also called Pascal second. This is the SI unit of coefficient of viscosity. Is it clear? Any doubt? No. So next, Stokes law of viscous force. Yes, Stokes law. What is the formula? Viscous force is equal to 6 pi eta RV, which is what? Terminal velocity. Viscous force, eta is a coefficient of viscosity. R is a, what is the concept? That is, a spherical body is falling through the viscous medium. Yes, then R is the radius of that spherical object or the body which is falling through the viscous medium. Eta is the coefficient of viscosity. Then what is the terminal velocity? Vt is equal to 2 by 9 r square g eta upon sigma minus rho. Again 2 by 9 is there, eta is the coefficient of viscosity, r is the radius of spherical body, g is the acceleration due to gravity, sigma is the density of spherical body and rho is the density of viscous medium. Okay, this is formula to calculate the terminal velocity. After some time the body is what? Coming down with certain constant velocity, that is called the terminal velocity. Okay, next one. Equation of continuity. Yes, what is the equation of continuity? First tell me, what is the volume rate? Volume rate is the what? dV by dt. Now see, यहाँ पे V is not velocity, V is the volume, and this one is also called the discharge. And what is this? It is the area into velocity. Area into velocity. Volume rate, that is volume upon time, which is called the discharge, which is equal to area into velocity. So वहां से equation of continuity is what? Volume flow rate remains constant. That is the Q1 is equal to Q2. Means we can say that A1 V1 is equal to A2. When to remember, this is capital V is the volume, small v is the velocity. Is it clear? Okay. Next. Then Bernoulli's equation. What is the Bernoulli's equation? Yes, it is the P plus half rho V square plus rho GH remains constant. So what is the P? P is called the what? That is the pressure head. Then what is half rho V square? It is called kinetic head. What is the rho GH? Which is called the potential head. If both the surfaces, both the conditions are at the horizontal level, if you are considering the Bernoulli's equation, both the pipes are at the same horizontal condition, then it remains cancel. Only the pressure and kinetic is remains present. So यहाँ से equation क्या बनता है बच्चों? Constant मतलब P1 plus बोलो half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. This is called the what? Bernoulli's equation. Okay, next. Speed of efflux. What is the formula of speed of efflux? Yes, we are taking the some horizontal, that is then, yes, bolo, This one represents the what? Height, that is represent. Suppose this liquid is present up to the height h. Okay. Then amount of water, speed of water flow, liquid coming outside this small hole. Okay. Efflux. Okay. This is h is the height up to which the liquid inside the container up to the height h. Now see, suppose I am considering these are the what? Small hole. Uska kuch to area hoga. इसका कुछ तो एरिया होगा. फॉर्मूला इज व्हाट बेसिकली v2 square 1 minus a2 by a1 square. Now I am going to clear that what this a2 is the area of what? Small hole, and a1 is the area of this tank or the container. Correct. Now just for understanding ऐसा consider किया कि this a2 is the what? इसका area. Suppose this is only 4 meter square and this one is a 400 meter square. So 4 upon 400 becomes 1 by 100. So 1 by 100 10 raised to minus 2. Minus 2 ka square minus 4. Means this ratio is what? Very very small. So approximately this value become 1. Any doubt? Next, Venturi tube. What is the equation for Venturi tube? Yes, that is 2GH is equal to V2 square minus V1 square. Venturi, याद है आप लोगों को? This is like this. This is a convergent section. Okay, this one is called the throat section, this one is a divergent section. So here is the what? V2, here is the what? Speed is the V1. Okay, at throat section what happened? Bernoulli's basically क्या कहता है? Pressure is inversely proportional to velocity. Pressure is inversely proportional to velocity. All these are speed of efflux, venturimeter, all these are the what? Applications of Bernoulli's theorem. Clear? Any doubt? Okay, so this is all about the formula of the what? Mechanical properties of fluids. Okay, ठीक है.
तो बच्चों, अगर आपको मेरा वीडियो पसंद आया है तो डू नॉट फॉरगेट टू लाइक, शेयर एंड सब्सक्राइब. तो पढ़ते रहो फिजिक्स विद वैभव सर.